Hello, everybody, and welcome to another episode of the Extreme Performance Series. My name is Todd Muirhead. I'm from the VMware Performance Engineering team. And in this series, I talk with various people all across the company about different cool performance things that are going on. So today, I have one of our vSAN experts with us, Pete.
Todd, hi there, everyone. My name is Pete Koehler. I'm a part of the VCF product team here at Broadcom, focus on all things vSAN. So as you can imagine, that's what we're going to be talking a little bit about here today.
You've got some really interesting stuff to share with us today about some competitive testing that was done at a customer.
Yes, indeed. Yeah, we had really the good fortune of having one of a very important customer of ours share with us some of the evaluations that they did in their environment. So when we think about storage performance testing, a lot of times, we have our customers, they ask us a little bit about vSAN and say, well, how fast is it? And of course, that is such a simple question, but it really depends on a wide variety of factors as far as what the actual answer is. And so oftentimes what we highly suggest is that after maybe an initial design or an evaluation of what the customers may have in their environment, that they perform some real testing in environment so that they can know and really understand how vSAN is going to be performing in their environment. And this is exactly what we had occur with one of our recent customers. What they did was they performed a series of evaluation at testing, but what I really appreciated about it was that they did two different approaches for testing. They did a classic synthetic IO generator testing, which is shown on the right-hand side of this slide, which is something that many of us are familiar with in sort of the storage industry. How many IOPS, how much throughput, what's the latency look like, that type of thing. But perhaps the more intriguing testing that they did was more focused on the application side of the house. So they wanted to better understand, can my applications meet some of the expectations, some of the performance expectations running on vSAN, and how does that really compare to how they operate on their existing very popular storage array. And so that's exactly what they did here. And we found the results really interesting. So we thought we would share them.
So yeah, I see here that they looks like they use 50 SQL Server VMs, and I'm assuming this is because they're using SQL Server in their real environment, and they wanted to simulate that as closely as possible for these tests.
Yeah, indeed. So they had on their existing infrastructure, they had a farm of 50 SQL servers. So they really wanted to emulate that as much as possible. And in that arrangement, it was a series of 50 SQL VMs. And so on the comparing vSAN cluster, which was 6 hosts, they also wanted to run 50 SQL VMs. And when you do this sort of a performance evaluation using this approach where you're focused really on the application, you have to understand that it's not going to drive the maximum potential amount of bandwidth or IOPS that the entire storage system can achieve, but rather help you better understand how is my application going to actually behave. And so what we see here is that when they performed the testing on their existing storage solution versus vSAN, that even though it's bound by the actual application itself, vSAN was able to achieve 20% better performance. So in translating in to IOPS, while still being able to meet the same level of latency. And that really mattered for this customer who was focused heavily on these highly transactional databases that were very latency sensitive.
Yeah, so it's key, like you said, to test as close as you can to your real environment. And this more realistic environment, you can see that the IOPS are much lower than what was achieved with the synthetic workload, which is cool. I mean, it's a real thing that you do with the FIO. But it's not really similar in a lot of ways to what they're actually doing with their applications.
Yeah, and more than anything, I think that this was really important for them to win over the application owners within the organization. It wasn't just about storage testing within the storage team. It was about getting buy-in across the board. They fully understood here's an opportunity to provide storage in a completely different way than they had historically done for these tier one applications. But they needed to validate it, and rightly so. We would all do that if we were in those very same circumstances. And this was something that, while we weren't surprised at all, because we've had several customers share similar notes with us, but this particular customer was very enthusiastic about the results.
Yeah, really great results. Good to see some real world type of testing showing significant improvement.
And we can't forget that even though when we think about a synthetic IO generator, something like FIO, that even though that isn't necessarily reflective of real world applications, it still can serve a very important function within an organization. You can stress test the actual storage solution itself. You can stress test the fabric that is connecting, all of the pieces of the puzzle together and so forth. And in that particular case, you can see a significant performance gain that vSAN ESA has over this competing storage array. And this was something that I think also caught them off guard a little bit. One of the other elements that this customer was really focused on, of course, was cost as it related to what they were achieving in terms of the performance, because no, single element lives in a vacuum. It's all interrelated. So if you have a solution that's going to deliver something, it needs to be able to show that benefit in a really effective way. And we know that from a traditional three-tier storage architecture, that one of the challenges in that type of architecture is that you have this relatively large step function in terms of capital expenses. If you're growing your storage environment, you have to buy another array and then another array and additional shelves for those arrays and so forth. Well, since vSAN is simply a distributed storage solution that is made up of physical servers, that step function is much smaller. So you can grow at a much more incremental pace than you would with a traditional storage solution. So after they did all of their evaluation and their calculations of cost on using VMware Cloud Foundation as the full stack sort of virtual private cloud environment, they concluded that was going to be 31% lower cost compared to using VCF using the storage array. Now, when we think about this idea of having integrated storage that is built right in to the hypervisor, sometimes we're doing sort of this comparison between a traditional three-tier arrangement and a hyperconverged arrangement, that being vSAN. It's worth kind of reminding everyone, though, there's a few functional differences between the two that makes having this fully integrated storage solution really intriguing. When we think about a vSphere cluster using a traditional three-tier architecture, you have this really sophisticated hypervisor. It's just doing extraordinary things in terms of compute scheduling and memory management and just all of those things that we were blown away with for many years. But when it comes to storage, it generally hands off all of those responsibilities to a storage array. And with that, you lose a lot of the control and the visibility of those IOs that are being sent and received by the given storage array. When we think about vSAN, whether it be in a fully aggregated arrangement or a disaggregated arrangement using a vSAN storage cluster, we have full control of those storage IOs from end to end. The moment that those IOs leave the VM and the vSCSI layer and traverse through the entire stack and land on the persistent storage, we can control and shape that traffic based off of our own scheduling mechanisms. And because of that, we also have complete visibility of that storage I/O as well. So not only are we able to tune and adjust the performance capabilities of vSAN, but we can provide a lot of visibility of those I/Os, and if there's a performance issue, some sort of contention within the stack, we can even show that within the vCenter Server UI as well. So really powerful aspect to vSAN that sometimes gets overlooked when we're sort of doing this direct comparison from a traditional solution over to vSAN.
Yeah, so it's all managed and monitored through VCF. There's no having to click over to some other control plane for your external storage array. So yeah, that's definitely a clear advantage.
Yeah, when you think about it, you have something like VCF operations, for example, which has always been a nice tool that can look at things beyond just a given cluster. You can look at things that, across workload domains and management domains and multiple VCF instances. That becomes really powerful because it's using the proper tool to measure the data in the right way from the right location and using the same method of measurement. And we do that, of course, through all of the nice APIs through vCenter Server and ESXi. And that helps normalize what we're actually looking at. What's my latency? What is some of the effective throughput and the IOPS that are occurring? We know that it's all being measured the right way because it's using the same APIs that are fetching the very same data that we see in vCenter Server.
Yeah, so I think it's very clear from this comparison that vSAN has advantages over traditional array. I think a lot of people would assume maybe that the performance was better with a traditional, like, external storage array. So this comparison is good to show that that is actually not the case. In addition to the performance, there's some other advantages as well that we talked about. So really, really great stuff. And I did want to mention that there's a blog post that Pete published not too long ago, and I'm going to link to it in the notes for this video if you want to go and read about this even more in your free time.
Thank you very much, Todd. Really appreciate you having me on.
Yeah, thanks for spending the time, Pete. So I'd like to thank everybody for tuning in, and I hope to see you soon on another episode of the Extreme Performance Series. Thanks, everybody.